I am sure that at least once in your life you have wondered why physical processes occur in the direction they do, rather than in some other way. And I am almost completely sure that you have heard the term entropy at least once. And if we draw an invisible line between the direction of physical processes and the measure of disorder in a system, as we are used to hearing in schools, universities, and so on, regarding entropy, an interesting parallel will emerge. Essentially, entropy determines the direction of physical processes. So, what is entropy itself and why does this happen? We will discuss this today. If you ask each of you what entropy is, or ask any student you catch in the hallway between classes, they will tell you, entropy is a measure of disorder in a system. And this jagged version of the definition essentially undermines all understanding and creativity. And this huge, all-encompassing concept, which deserves, I don't know, a dozen videos on the topic, is condensed into such a thing. A measure of disorder in a system. To some extent, this is correct. In fact, the more ordering we have, the lower our entropy. Well, the system, paradoxically, usually tends to move from a direction of greatest order to a state of least ordering. The thing is, in order to maintain a specific state, energy must be expended. And this is energetically unprofitable. And according to all existing laws of the universe, I won't list specific laws, I think that's not important right now. The system will strive to maintain the most energetically favorable state. This can explain almost all ongoing processes. For example, why you will get shocked if you touch a bare wire while standing on wet ground. The fact is that it is more advantageous for the system to conduct electric current through you rather than through the circuit that existed before. Therefore, based on this, any system will tend to move from a more ordered state to a less ordered one. The more information we have about the system, the more we can actually organize the system. And therefore, the second definition that exists, and that you may have also heard, is based on the idea that entropy is how much we know about the system. Here we should again return to the nature of chaos, let's call it that. Fact is that in chaos no one knows anything. But if we try to organize this chaos to find some connections, then actually we have this interesting notion that entropy decreases. Entropy decreases as information about the system emerges. Why? In fact, this is quite a complex, even a worldview principle, but in some sense it can be transferred to a simple experimental study of any sample. I believe that any randomness is a lack of sufficient information. In fact, a random event has maximum entropy. If we had some information about this event, then the entropy would be lower, and we could say that this event follows certain cases. And in the case of randomness, this is also a very important point. Randomness would not be random if we understood the situation properly. And in the case of discussing randomness, as they say, at some point, a certain number of uncertain factors accumulate, so the event will still be considered random. But the mechanics of this event are not random at all, and in this case, again, we encounter what entropy is. The next point about entropy is the description of the direction of a physical process. Inevitably, a hot kettle placed outside in the cold will cool down. In fact, any process is directed from the state C. From a state of lowest entropy to a state of highest entropy. Might ask, how does this work? Well, there were particles that were ordered into some structure, or particles that had some heat and a certain thermal energy. The kettle began to cool down, and it is energetically more favorable for the particles to transition to a free state. This free state is technically more complex to describe, so one can even say that the entropy of such a state will be increasing, and that is why we have what we have. In fact, entropy is also used to describe the directions of the flow of physical processes. And if we talk about the fact that a physical process occurs in this direction and not in another, we can say that this happens because that is the nature of entropy. There is another interesting point. Entropy is often linked to the arrow of time, and these moments intersect to some extent. Why does time move in one direction? This is a completely global question. But again, very often either a student or a person who enjoys watching popular science physics videos will tell you that the direction of time is determined by the direction of entropy. Well damn, can't argue with that. And in general, he is right, except for one thing, it doesn't clarify anything. But what is important for us now is different. We are currently discussing the concept of entropy itself. In this case, it can be said that the direction of entropy will coincide with the direction of the arrow of time. And the direction of the arrow of time is determined by the direction of entropy. Thus, another definition of entropy is a way to describe the direction of a physical process and the direction of the flow of time. The most interesting thing here is that if I were to ask you right now, why is it like this? There is no answer to that. But one can always say that it is because entropy is always directed this way, and that is how the universe is arranged. The other thing is that even if we say this, it actually clarifies nothing. Because from a physical point of view, we do not understand why this happens. And interestingly, if you read the works of physicists on this topic, you will encounter an interesting situation. Do you remember Boltzmann? I constantly think about him. On the channel about inventions, link in the description, be sure to check it out. I have written about him a couple of times, his magnificent concept of Boltzmann's brain. And in general, this scientist, let's say, has a rather unfortunate fate. Because in my opinion he was, how should I put it more gently, bullied. Probably. He was so bullied that the guy hanged himself in a mental hospital because his concept was ridiculed. And the person, to put it bluntly, lost any scientific respect. But the most characteristic thing here is that after some time it turned out that Boltzmann's ideas were correct. So, he had a statement regarding entropy. We just talked about Maxwell's demon and mentioned that to some extent it illustrates why all processes occur in this way. And most importantly, it illustrates why processes can technically, let's say, go in the reverse direction, and nature itself doesn't seem to prohibit this. It is some, let's call it, control system that does, if you will. And what is important here is not that the process occurs in any specific direction. The most important thing here is that the process can occur in some other direction with a certain probability, and that probability is incredibly low. There is a non-zero probability that right now all objects will start to rise into the sky instead of falling to the ground. Here, it can indeed be related to gravity, because these questions are controversial and complex. But perhaps it is more correct to talk about the direction of the flow of the process. Roughly speaking, I will repeat this example that has already been mentioned. A kettle in the cold can, with a non-zero probability, start to heat up. And here, Maxwell's demon could help us if he existed. But again, I will say that nature does not directly prohibit this. Well, my friends, I hope that the information you have received now will help you understand and grasp this complex physical term more easily. To some extent, one can say that entropy is the most uncertain physical parameter. The most uncertain physical indicator. The fact is that there is no direct definition of entropy, and as you have probably realized from what we have discussed, entropy can be understood in many different ways. Well then, I ask you to subscribe to the Telegram, like, and subscribe to the channel. Thank you again for your attention, see you soon, and goodbye everyone.